Now that we have learned how to handle each of the three different forms of a quadratic equation, our vertex form, standard form, and intercept form, now we're going to put them all together to try to solve some equations using graphing. So in the last unit, as we were factoring our polynomials, there we were solving equations by factoring. We were splitting it into pieces, setting them equal to 0 using our zero product property, and finding our solutions. Now we're going to find those solutions using our graphs instead. So the key is going to be that we want to find the x-intercepts, or the zeros. That's going to be our solution. Okay? So what we're really looking for is, where do these equations cross the x-axis? Where is the y equal to 0? What x values work? Okay? So when we do them, we're going to set the equation equal to 0, just like last unit. But this time, instead of solving them with algebra, we're going to solve them by graphing. Okay? We'll use each of the different techniques and things that we've learned for the different forms. And then our goal is to find out, does it have two solutions? Does it have one solution, or does it have no solutions? Depending on how many times it crosses the x-axis, it's going to have that many solutions. So for instance, in my graph over here, it crosses kind of in two different points. Those would each be my solutions. So if we kind of estimate them a little bit, this one looks like it's at -1, 0, and this one is at 3, 0. So those would be my x-intercepts. My solution is going to be that -1 and that 3. So when a problem asks for the x-intercepts, we want the coordinates for those points. When it asks for the solution, we just want to know those x values. What x values could I plug in here that would give me 0 for y? Where is it going to hit that y, or hit that x-axis? Okay. We can determine the number of solutions by looking at the graph. Sometimes there's going to be two solutions, and when that happens, it's going to look something like this. It's going to hit the x-axis at two specific points, so that has two solutions. For one that has one solution, that's going to look like this. Okay? And it could be anywhere on the graph, but it only hits the x-axis at one specific point. In this case, our vertex is going to be that solution. And then when it's no solutions, that's where our graph never makes contact with the x-axis. It's either above it or below it and never actually intersects with the x-axis, meaning there are no x values that we could plug in to give us a solution. There are no x's that will give us 0 for y. All right, so the whole point of today's lesson is kind of taking everything and putting it all together. So our goal is to identify what kind of form is my equation in. How do I use that to find things like my axis of symmetry and my vertex? We'll use our table of values from our calculator to give us some additional points, and then we'll go ahead and graph it and solve it from there. But again, our ultimate goal is to know what those x-intercepts are, or what that solution is going to be. So for the first one, this one is in standard form. Okay? So standard form is the one that takes a little bit of work. To find my axis of symmetry, I want to do the opposite of b over 2a. So my b is 1, so the opposite is -1 over 2 times a, which is 1. So my axis of symmetry is -1/2. So I'm going to have a line going down here. It's hard to draw in between, but kind of in between at that -1/2. To find my y value, I'm going to plug my x back into my equation. So I'm going to have -1/2 squared plus -1/2 minus 6. -1/2 squared is 1/4, plus -1/2 minus 6 gives me -6 and 1/4. Or you could say -6.25 if you want to write it that way. So my vertex is at -1/2 and -6 and 1/4. So I can plug that in here. So I get -1/2 and -6, 1, 2, 3, 4, 5, 6, and 1/4. That's going to be my vertex. All right, now I need to graph the rest of the equation, so I'm going to have to find some x's and y's using my calculator. So I want to be centered around that negative 1/2. So negative 1 is at negative 6, negative 2 is at negative 4, negative 3 is at 0, and negative 4 is at positive 6. So go ahead and plot my points. So negative 1 and negative 6. So I know 0 and negative 6. And then negative 2 and negative 4. And 1 and negative 4, because I always have those matching partners. Negative 3 and 0. 2 and 0. Negative 4 and 6. 3 and 6. So I use my calculator to find those table of values so I can graph the rest of my equation. But what I really want to focus on is where does it cross the x-axis? Those are my solutions. So it crosses at negative 3, 0, and it crosses at 2, 0. Those are my two solutions. So those are my x-intercepts. To write them as my solutions, I just write them as negative 3, 2. Now, if we didn't have a graphing calculator or we wanted to check to make sure we had done it correctly, we could actually do the same work by factoring. So say I had x squared plus x minus 6 equals 0. I could factor it into x plus 3 and x minus 2. I can set each one of those equal to 0. So x plus 3 equals 0, so x is negative 3. X minus 2 is equal to 0, so x is equal to 2. I get the same negative 3 and 2 for my solutions. So I can very easily check to make sure I solved it correctly. All right, problem 2. Problem 2 is in vertex form. So pull out that necessary information. So I know my axis of symmetry is 3. I know my vertex is 3 and negative 8. Remember, our vertex form just lets us pull that information right out of the problem. So I know my axis of symmetry is at 3. I know my vertex is at 3, negative 8. Okay. To go from here, I'm going to need to plot some additional points. So I'm going to type it into my calculator. So 2 times x minus 3 squared minus 8. I'm going to go ahead and graph it. Okay. I know my negative 3 is at negative 8. Negative 2, or sorry, my positive 3 is at 8. My 2 is at negative 6. 1 is at 0. 0 is at 10. So I can go ahead and plot my points. So 2, negative 6, 1 and 0, 0 and 10. And then I can do my mirror image. So I've got one here, here, and here. I can draw my graph to finish my graph. And then I can look for those solutions. Remember, I want to know those x-intercepts. Well, it crosses at 1 and it crosses at 5. So I have the points 1, 0, and 5, 0 are my intercepts. And that means my solution is 1 and 5. All right. Say we want to check this one to see if we've done it correctly. So we can actually solve this equation and try to figure out what the x value is going to be since it's equal to 0. So I have 2 times x minus 3 squared minus 8 is equal to 0. So I'd solve it by adding 8 to both sides. And then I'm going to divide everything by 2 to get rid of that 2. And I get x minus 3 squared is equal to 4. Okay, the next step is just a little bit different. We want to unsquare it. So to unsquare something, we take its square root. So the square root of x minus 3 squared is x minus 3. The square root of 4 is both positive 2 and negative 2. So I actually get 2 different solutions. So I'm going to solve it 2 different ways. I'm going to solve it x minus 3 equals positive 2, and x minus 3 is equal to negative 2, because I want to allow for both of those possibilities. Well, Here I would add 3 to both sides and get x is equal to 5. Here I'd add 3 to both sides and get x is equal to 1. The exact same solutions that I got from graphing. So it's an easy way to check that solution. All right, last one. It's in intercept form. So we should very easily be able to find those intercepts. I know it's going to cross at an x of 1 and 0, and then an x of 3 and 0. I don't know why I keep wanting to write the x instead of the 3. We're just taking those values that are being subtracted from x. So those are my intercepts, 1, 0, and 3, 0. So my solutions are going to be 1 and 3. Okay. But we still want to go ahead and graph it as well. So we need to find that axis of symmetry. That x value, well, I've got 1, 0, and 3, 0. So my axis of symmetry is going to be in the middle at 2. So I'm going to draw that line down. To find my y value, I'm going to plug in my x. So 4 times 2 minus 1, and then 2 minus 3. 2 minus 1 is 1. 2 minus 3 is negative 1. Times 4 is negative 4. So I know my vertex is at 2, negative 4. And then I can go ahead and graph the rest of this using my calculator to give me some additional points. So 4 times x minus 1 times x minus 3. I know my vertex is at 2, negative 4. I have 1 and 3 are both at 0. 4 is going to be at 12. So 0 is going to be at 12. And I can draw my equation. Okay. So no matter what form the equation happens to take form, I can use my tools to find my axis of symmetry, my vertex. I can find some of the additional points for that equation and help me find my solutions, which are specifically where does it cross that x-axis? Where is y going to be equal to 0?